electricity generation, an electric generator is a device that converts mechanical energy to electrical energy. A generator forces electric charge to flow through an external electrical circuit. It is similar to a water pump since it allows electricity to flow but does not create electricity. The source of mechanical energy may be a turbine steam engine, water falling through a turbine or water wheel, or any other source of mechanical energy.
Due to rising costs of fossil fuels, renewable resources such as hydroelectric, solar, and wind turbines are being developed at an increased rate since they provide a more environmentally friendly and renewable way to generate electricity.
A wind turbine is a device that converts kinetic energy from the wind into mechanical energy, a process known as wind power. The result of over a millennium of windmill development and modern engineering, today's wind turbines are manufactured in a wide range of vertical and horizontal axis types. The smallest turbines are used for applications such as battery charging or auxiliary power on boats, while large grid-connected arrays of turbines are becoming an increasingly important source of wind power produced commercial electricity.
We've all seen those creaky old windmills on farms, and although they may seem about as low-tech as you can get, those old windmills are the predecessors for new modern wind turbines that generate electricity. The same wind that used to pump water for cattle is now turning giant wind turbines to power cities and homes. Okay, have a look at this wind farm in the California desert. A hot desert next to tall mountains, an ideal place for a lot of wind. Here's another one on the windy prairies of Wyoming. Now, today's wind turbines are much more complicated machines than the old prairie windmills, but the principle is the same. Both capture the wind's energy. Okay, here's how it works. First, a wind turbine blade works sort of like an airplane wing. Blowing air passes around both sides of the blade. The shape of the blade causes the air pressure to be uneven, higher on one side of the blade and lower on the other. And that's what makes it spin. The uneven pressure causes the blades to spin around the center of the turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now the blades are attached to a shaft which only turns about 18 revolutions a minute, and that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1,800 revolutions per minute. And at that speed, the generator can produce a lot of electricity. So, why are wind turbines so tall? Well, the higher up you go, the windier it is. More wind naturally means more electricity. And in many cases, larger turbines can also capture wind energy more efficiently. The blades can sweep a circle in the sky as long as a football field. Now, what's really cool is that even a small wind farm, like this one in Wyoming, can generate enough electricity to power more than 9,000 homes. And larger farms can provide much more clean energy for our homes and businesses.
Solar power is the conversion of sunlight into electricity. Early forms of solar power were concentrated solar power, or CSP. Concentrated solar power systems uses lenses or mirrors and tracking systems to focus a large area of sunlight into a small beam. Most new solar panels are using photovoltaics or PV. Photovoltaics convert light into electric current using the photoelectric effect. Here's a video explaining the process of photovoltaics.
Alright, we all know that the sun's energy creates heat and light, but it can also be converted to make electricity, and lots of it. One technology is called solar photovoltaics, or PV for short. You've probably seen PV panels around for years, but recent advancements have greatly improved their efficiency and electrical output. Enough energy from the sun hits the Earth every hour to power the planet for an entire year. Here's how it works. You see, sunlight is made up of tiny packets of energy called photons. These photons radiate out from the sun, and about 93 million miles later, they collide with a semiconductor on a solar panel here on Earth. It all happens at the speed of light. Take take a closer look, and you can see the panel is made up of several individual cells, each with a positive and a negative layer, which create an electric field. It works something like a battery. So, the photons strike the cell, and their energy frees some electrons in the semiconductor material. The electrons create an electric current, which is harnessed by wires connected to the positive and negative sides of the cell. The electricity created is multiplied by the number of cells in each panel, and the number of panels in each solar array. Combined, a solar array can make a lot of electricity for your home or business. This rooftop solar array powers this home, and the array on top of this warehouse creates enough electricity for about 1,000 homes. Okay, there are some obvious advantages to solar PV technology. It produces clean energy, it has no emissions, no moving parts, it doesn't make any noise, and it doesn't need water or fossil fuels to produce power. And it can be located right where the power is needed, in the middle of nowhere. Or it can be tied into the power grid. Solar PV is growing fast, and it can play a big role in America's clean energy economy, anywhere the sun shines.
Hydroelectricity is the term referring to electricity generated by hydropower, the production of electrical power through the use of the gravitational force of falling or flowing water. The cost of hydroelectricity is relatively low, making it a competitive source of renewable electricity. Here's a video further explaining the process of hydroelectricity.
"170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called a stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.